dimensional analysis. That's one of the most important part of this course, and this is something that you're going to need in the future. So any kind of synthesis stuff you're going to do this every single time. You have to calculate your reactants or anything. You need dimensional analysis. Okay, so dimensional analysis is used for solving chemical problems. It is very important. It's also called factor label method. It's used to convert between desired units. Okay, dimensional analysis is the process of converting between units. And we do this for doing the dimensional analysis. We have to learn just the connections, just to learn the connection, memorize the connection between the units, and we can use them to convert between our units. And how are we going to do that? So I'm going to start with this very simple. So can you tell me, what does any number divided by itself equal? If you choose 1, you're right. Okay, so if you divide 10 by 10, it's 1. If you divide 47 by 47, it's 1. So if you divide any number by itself, it is 1. Okay, for example, we say there are 12 donuts in a dozen. Okay, or we can write it 12 donuts equal 1 dozen of donuts. Okay, so if these two are equal, if I write 12 donuts divided by 1 dozen of donuts, what is the answer? I'm dividing something by itself because they're equal, right? So what's the answer? It's 1, right? So what does any number, now this is the next simple question, what does any number times 1 equal? If you choose that number, you're right. Like if you multiply 10 by 1, what does it equal? 10. 47 by 1, and I just choose 47, I don't know, for some reason. So it's 47. Okay, so if you multiply any number by 1, it's that number. Okay, you don't change anything. So dimensional analysis is using these two simple rules to convert between units. It seems simple, right? So let's try it on some examples. In our first example, we have how many donuts are in 3.5 dozen. Okay, so going back to our first example, so we know that 12 donuts are 1 dozen. Okay, so we can say 12 donuts over 1 dozen, it's 1, right? Or is it different if I say 1 dozen over 12 donuts? It's still 1, right? So both of them could be 1, and that's what we are going to call it conversion factor. Okay, so you get the conversion factor from any kind of equality. Okay, so we have our equality here, and we get a conversion factor. We can always get 2 conversion factor from any equality. Okay, because it doesn't matter which one goes to the top or bottom. Okay, it's us who decide which of these two we're going to use, and I just mentioned this a little bit in the previous recitation. Okay, so here we are trying to convert 3.5, and it's better to write it this way, dozen. Okay, so I have dozen. I want to know how many donuts. Okay, so you multiply, if these two equal 1, if I multiply this by 1, what happens? Nothing happens, right? So we don't change the number, but you can use these two conversion factor to convert dozen to donuts, okay? So we multiply this by one of these two. Which one of these two do we choose? Well, to decide which one, you have to see your unit, which is dozen in this case, and you want to get rid of that, right? So if you have something which is on top in denominator and you want to get rid of that, you have to have the same thing on the bottom so you can cancel those two together, right? So if dozen is over here, I need dozen to be here so I can cancel them, okay? So which one of these two we have to use, 1 or 2? Yes, we are going to use conversion factor number 1. So 1 dozen is 12 donuts, right? So we can cancel dozen with dozen, and then what we have is donuts. So let me erase this part. Okay. So in the end, we have the unit as donuts, and the rest is just putting these numbers in your calculator, okay? If you multiply these, you get the number, and that is 42. So you have 42 donuts in 3.5 dozen. So let's see our next example. How many meters are in 3 kilometers? Okay, so first you have to find your equality. Okay, so what equality do we have that relates kilometers to meters? Okay, so we know that 1 kilometers, and we talked about this before, always 1 goes with the prefix, and the definition, what is the definition of kilo? It's 10 to 3, goes with the base unit, meter. Okay, so we have our equality. Now which conversion factor do we have to use? So we start with the given, always we start with the given information, which is 3 kilometers. Okay, and we multiply it by a conversion factor. So a conversion factor could be 1 kilometer over 10 to 3 meter, or 10 to 3 meter over 1 kilometer. We have kilometer here, and we want to get rid of that, so we put kilometers here. So therefore, we have to put 1 kilometer on the bottom and 10 to 3 meters on top, okay? So we can get rid of kilometer with kilometer, and our unit is meter. The rest is just doing the math, put the numbers, and write the answer. So it's 3 times 10 to the 3, or 3,000. Okay. So let's have our next example. How many micrograms are in 0.040 gram? And this time we want to check it with the right number of stick fig. Okay. So it always helps if you start with making this chart of given, wanted, convert or conversion, and what do we know about this conversion? Okay, so the given is always the data that you see in the question. What information does the question give? Okay, so we have this data in the question, so the mass is 0.040 gram. Okay, what does the question want? Okay, it says how many micrograms, so it's asking for microgram. Okay, and we show micro with this microgram. Okay, so what is the conversion? What do we want to convert? You want to convert gram to microgram. Okay, what do we know about this conversion? Well, if you remember the prefixes, micro means 10 to negative 6. So we know that 1, and again, 1 goes to the prefix, and the definition of the prefix, which is 10 to negative 6, goes to the base unit, gram. So 1 microgram is 10 to negative 6 gram. Okay, so we have this equality. We can make our conversion factor with that. So you always start with the given information. You start with this. So 0.040 gram times, we have to multiply it by a conversion factor. Okay, we have this equality, we have gram here, we want to get rid of gram, so I know that gram should be here and microgram should be on top. So from our equality, I know that 10 to negative 6 gram is 1 microgram. Okay, so you can get rid of gram with gram and you end up with microgram. So your final answer is in microgram, and that's what we wanted, so we're good. Okay, the rest is just putting these numbers in calculator. So it's 10 to the 6 goes to the top, it's 10 to plus 6, and removing this 2, so it's 4.0. I have to erase this part. Okay, 4.0 times 10 to 4 microgram. But does this have the right number of sig figs? So if you remember, for multiplication, the rule says the smallest number of sig figs, right? How many sig figs do we have in the first number? Because this is a conversion, this is not something you consider for significant figures. So the first number, how many sig figs does this one have? It has 2 sig figs, right? These are leading zeros. We do not count leading zeros, so we have 1 and 2. The trailing zero with a decimal place, we counted, so it has 2 sig figs. So your final answer should also have 2 sig figs. So this has 2 sig figs, so this is right. So the right answer is 4.0 times 10 to 4 microgram. These are some English metric conversion that you have to memorize. It's not going to be given in the exam, so you have to memorize these. An inch is 2.54 centimeter, and these are exact numbers. Okay, we talked about the exact numbers. So if the question is asking you the right number of sig figs, for example, if you're using this conversion, it's not like say, okay, so this has 3 sig figs. No, it has infinite number of sig figs, because you can put 0, 0, 0, 0 here until infinite numbers. Okay, so you do not consider these in your significant figure counting, but you have to memorize these conversion factors. Okay, let's have some other examples. So if a box is 3 centimeter by 5 meter and by 4 inches, so you have 3 different units. Okay, what is the volume of the box in centimeter? Okay, cubic centimeter. So for finding the volume, you have to multiply width, length, and height, right? And we have all of these 3, but we have it in different units. Okay, and we want the answer in cubic centimeter, so we have to get all of these lengths in centimeter. So the first one is already in centimeter, so we keep it like that, times the second one is in meter, so 5.0 meter, and I want to convert that to centimeter. So what do we have meter to centimeter? I know that first of all, we have meter here, so I have to put meter here to get rid of that, and I need centimeter. Okay, and I know 1 centimeter is 10 to negative 2 meter. Okay, or 100 centimeter is 1 meter. Okay, same. So that's our next one, our height, or I don't know, maybe it's length. And the last one is 4 inches. Again, we do not want this to be an inch, so I have to convert inch, because inch is here, I have to get rid of that, to centimeter. And with this equality, I know that 1 inch is 2.54 centimeter. Okay, so we had our height, we had the length, and we had the, where's the other one? I just missed it. height, length, and width. Okay, so we had these three, and if you see, we have meter here, cancel with meter. We have inches, cancel with inches, so we end up with centimeter, centimeter, and centimeter. So the unit is cubic centimeter. Okay, and that's what we want. Okay, so that's fine. And the rest is just putting these numbers in your calculator and this one and see, oh, I missed this one. Okay, so put these numbers in your calculator and see what's the answer. If you get the same number as I did, it's 1.5240 times 10 to 4, okay, cubic centimeter. And let me erase this part. Okay, so the answer is this, but do we have the right number of sig figs? So how many sig figs do we have in this first number? We have 2 sig fig here, 2 sig fig here. We do not consider the conversions because they're exact numbers. And 2 sig fig here. This is also conversion. We just talked about this. This is not 3 sig figs. It has infinite significant figures, so we do not count that. So the rule for multiplication says the smallest number of significant figures. Okay, so it has 2, 2, 2. So the answer should also have 2 significant figures. So we drop this from here, start from here, 1, 2. So the answer is 1.5 times 10 to 4 cubic centimeter. Okay, so let's have another example. The speed of sound in air is about 343 meter over second. Okay, what is this speed in miles per hour? Okay, again, let's write given, wanted, convert or conversion, and what do we know about these conversions. Okay, so what is given? The given is the information, the question. So the given is 343 meter over second. Okay, what is wanted? We want the speed in miles per hour. Okay, that's what we want. What do we need to convert? We need to convert meter to miles. So it was better to talk about it a little bit. So we want to convert meter over second to miles per hour. Okay, but it's not like we have a conversion directly with these two ratios as speed unit. Okay, but we know the length unit is in meter in here, and we want it in miles. So the length unit needs to be converted from meter to miles, and the time unit needs to convert from second to hour. Okay, so what do we know about these conversion? So the first one is given in the question here. So we know that 1 mile is 1609 meter. Okay, what about the time? The second to the hour. You can directly says 1 hour is 3,600 seconds, or you can relate it with two equalities. Like we know that 1 minute is 60 seconds and 1 hour is 60 minutes. Okay, and I have to change the color not to mix up. So we know all of these equalities, we know our conversion, we know what is given and what we want. Okay, always starts with given. Okay, and it's better, so when you have a unit which is in a ratio form like this, like meter over second, like I don't know, gram over cubic centimeter, kilogram over liter, or whatever. Okay, if you have any unit which is in a ratio form, you can take that as a conversion factor sometimes, or you can write it as this, like this. So you can say 343 meter in 1 second. Okay, you can write it like this. Okay, so we want to start with our first conversion factor. Let's start with the distance, the length unit. Let's convert meter to miles because that's what we want, right? We have to go to mile. So we use this equality here. We have meter on the top, so I have to cancel that, so I have to put it on the bottom. So I have to go from meter to mile, and from our equality we know that 1609 meter is 1 mile. We do not stop here because we're done with a meter and mile. We have to convert the time unit. So we have second here, and I want to get rid of that. I want to cancel that. Since the second is on the bottom, I have to put the second in top in my conversion factor. Okay, so it can be canceled. So in my equality column, I have second to minute. Okay, so second to minute, I know that 60 seconds is 1 minute. But are we done? No, because we want the time unit in hour. Okay, so still we have to continue. We have minute here, we have one more equality here. Minute, I want to get rid of that, it's on the bottom. I have to put it on top. Okay, and I need it in hour. Okay, and I know 60 minutes is 1 hour. Okay, so I have to move this a little bit. Okay, so are we done? Let's see. So let's look at the units. We have meter goes with meter. We have second here that goes with second. We have minutes with minutes. What's left off? We have miles here and hour here. So the units will be miles an hour. Is it good? Yes, that's exactly what we want. Okay, so if the unit is okay, miles per hour, if the unit is okay, it means we're done. So the rest is just dealing with the numbers. You just put the numbers in your calculator and find the answer. If you get 767 point, I always write four decimal places first and then take care of the sig fix. Okay, so if you get this answer, you're right. Now you have to check if how many sig fix we need. Okay, so these are conversion factors and they are exact numbers, so we do not count the significant figures in these conversion. The only thing that we have to care about is the first number, and how many sig fix do we have in there? We have 3 sig fix, so the final answer should also have 3 sig fix. So it's 1, 2, 3. We have to cut it here. Since the next number is 4, we do not round it up, so we leave it as 667 mile per hour. So it's pretty fast, huh? Okay, so let's go to the next example. How many cubic centimeter are in 15 cubic meter? Okay, again, let's set up our chart. What is given, what is wanted, what do we need to convert, and what do we know about this conversion? Okay, so the given is the given information, so we know it's 15 cubic meter. What is wanted? We want it in cubic centimeter, so that's wanted. What do we need to convert? We need to convert cubic meter to cubic centimeter. So in our charts of prefixes, do we know any conversion that can convert cubic meter to cubic centimeter? Well, I don't remember the direct conversion of these two, but I know that 1 centimeter is is 10 to negative 2 meter. right? We know that. But we need cubic meter and cubic centimeter. So how can we get that? So if we cube the whole equality, it doesn't change anything, right? For example, if 5 equal 5, and if I cube them, again, 5 cubed equal 5 cubed, right? I don't change anything. It's still valid. The equality is still valid, okay? So if you cube the whole equality, the cube goes to every single one of them. So it's 1 cube. It also goes to the units. So it's centimeter cubed equal 10 to negative 2 cubed and meter cubed, okay? 1 cubed is 1. It doesn't matter how many exponents you put on 1. So it's 1 cubic centimeter. So what is 10 to negative 2 cubed? You just multiply these two, okay, if you have two exponents on top of each other. So it's 10 to negative 6, and the unit is cubic meter, okay? So now I have an equality for cubic centimeter to cubic meter. I know 1 cubic centimeter is 10 to negative 6 cubic meter, okay? And this is not an equality that you have to memorize. This is something that you can derive. The thing that you have to memorize is this one. You should know that 1 centimeter is 10 to negative 2 cubic meter. And then you can cube the whole thing to get this, okay? Okay, so seems like we have the equality that we need. So let's start our dimensional analysis. You always start with the given information. So you start with the given 15 cubic meter multiplied by a conversion factor. So we have cubic meter here. I want to get rid of that, so I have to put it on the bottom because as soon as it's on top, and I go from cubic meter to cubic centimeter. And from our equality, I know that 10 to negative 6 cubic meter is 1 cubic centimeter, okay? So cubic meter with cubic meter, and we end up with cubic centimeter, and that's what we want, which is good. So this 10 goes to the top, and that's 10 to plus 6. It's 15 times 10 to 6 cubic centimeter, or 1.5 times 10 to 7 cubic centimeter. And we started with 2 sig figs, we end up with 2 sig figs, so that's the right answer, okay? In the last example, and we're going to have lots of more examples in the recitation, okay? So how many kilograms are in 2.9 times 10 to 11 milligram, okay? Again, given, wanted, convert, and what we know about this conversion. The given is given information, 2.9 times 10 to 11 milligram. What do we want? We want it in kilogram. What do we need to convert? We need to convert milligram to kilogram. Do we have a direct conversion from milligram to kilogram? No. But if you don't have a direct conversion, you can just check one of these two and go back to your chart of list of the conversions and see if you can find anything that have one of these units in it, okay? So we know that 1 milligram is 10 to negative 3 gram. Again, 1 goes with a prefix and the definition goes with the base unit, okay? 1 milligram is 10 to negative 3 gram. And 1 kilogram, what is kilo? It's 10 to 3. 10 to 3 gram, okay? So you see both of them have gram, so we can relate these two equalities and convert milligram to kilogram, okay? Okay, so let's start with the given information. So 2.9 times 10 to 11 milligram. We have to use our first conversion factor. We have milligram here, So I want to get rid of milligram, so I have to put milligram over here, and in our conversion factor I have milligram to gram, so milligram here and gram on top, and 1 milligram equal 10 to negative 3 gram. Always the top and bottom of your conversion factor should equal, so you have 1. Okay, so are we done? No, because we need kilogram. Okay, so we're not done. So we cancel milligram to milligram. We have gram here, but we don't want gram, we want kilogram. So I want to get rid of that gram, so I have to put it here so I can cancel it with that gram. And in this conversion factor, or let's say in this equality, we have gram to kilogram. So gram here and kilogram here, and I know 10 to 3 gram is 1 kilogram. Okay, and are we done? It seems so. So milligram with milligram, gram with gram, and we end up with kilogram. And what do we want? We want kilogram. Okay, so we are done. So as soon as you end up with the unit which is wanted, you're done. Okay, so when you're done, you can just stop, write the units, and the rest of it is just doing the math. Put these numbers in your calculator and come up with the answer. Seems like you don't even need a calculator. So if this goes to the top, it's 10 to negative 3, and you have 10 to the negative 3, 10 to the negative 3, 10 to 11. So these two are 10 to negative 6, and this is 11, so you subtract it, so you have 5. So it's 2.9 times 10 to 5. Okay, these are conversion. You have 2 sig figs here, and you have 2 sig figs here, so you're good. So the answer is 2.9 times 10 to 5 kilogram. Okay, I hope that you get the dimensional analysis. It's simple and it's very useful. You just have to learn how to use it. Okay, just get familiarized with the equality and the conversion factor concept. You can use as many conversion factor as you need. You just have to be careful with the units. You have to memorize the let's say the unit conversion bridges, so you know how to relate them, and you have to end up with what is wanted, the unit that is wanted. The rest is just putting the numbers in the calculator. It's easy, and come up with the answer.